An arrestor-rated surge protective device, or SPD, typically includes a metal oxide varistor, often abbreviated as MOV, a spark-over gap, and a surge counter or status indicator. A transient voltage surge suppressor-rated SPD, or TVSS, typically includes MOV and a transient voltage suppressor, or TVS. Arrestor-rated SPD are designed to protect against high-energy surges caused by lightning strikes or power surges. The MOV is the primary surge-absorbing element, while the spark-over gap provides a low-resistance path to ground for very high-energy surges. TVSS-rated SPD are designed to protect against transient voltage spikes caused by switching events or inductive loads. The TVS is the primary surge-absorbing element, providing a low-impedance path to ground for short-duration transients. Arrestor-rated SPD are typically UL 1449 listed, which covers their use in arrestor applications where high-energy surges are expected, for example, lightning protection. TVSS-rated SPD are typically UL 1449 Type 2 or Type 4 listed, which covers their use in TVSS applications where transient voltage spikes are the primary concern. NEC Section 280 requires that the SPD installed in the service entrance of a building where an explosive atmosphere is present be arrestor-rated. This is because arrestor-rated SPD are designed to handle high-energy surges that could potentially ignite flammable gases or vapors. Installing an arrestor-rated SPD in parallel with a panel installed SPD may be required due to the explosive requirement. The arrestor-rated SPD provides additional protection against high-energy surges that the panel-installed SPD may not be able to handle alone. To delve deeper into the nuances between arrestor-rated and TVSS-rated SPD, it's essential to understand the role and function of each component, and how they contribute to overall surge protection. Let's start with the metal oxide varistor, or MOV. The MOV is a voltage-dependent resistor. Its resistance varies with the applied voltage. At normal operating voltages, the MOV exhibits a high resistance, effectively blocking current flow. However, when a surge voltage exceeds a certain threshold, the MOV resistance drops dramatically, diverting the surge current to ground. This protects sensitive equipment connected to the electrical system. The MOV is a critical component in both arrestor-rated and TVSS-rated SPD, but the specific characteristics of the MOV, such as its voltage rating, surge current capacity, and energy dissipation capability, may differ depending on the application. Now let's discuss the spark-over gap. The spark-over gap is a component unique to arrestor-rated SPD. It consists of two electrodes separated by a small air gap. Under normal operating conditions, the air gap acts as an insulator, preventing current flow. However, when a very high energy surge, such as a lightning strike, occurs, the voltage across the gap exceeds its breakdown voltage. This causes the air to ionize, creating a conductive path that allows the surge current to flow to ground. The spark-over gap is designed to handle extremely high surge currents that MOV alone might not be able to withstand. It provides an additional layer of protection against catastrophic surges. The surge counter or status indicator is another component often found in arrestor-rated SPD. This device tracks the number of surge events that the SPD has experienced. It can provide valuable information about the frequency and severity of surges in the electrical system. The status indicator may also alert users when the SPD has reached the end of its service life and needs to be replaced. Now, regarding the transient voltage suppressor, or TVS. The TVS is a semiconductor device that provides overvoltage protection. Like the MOV, the TVS acts as a voltage-dependent resistor. However, the TVS typically has a faster response time and lower clamping voltage than the MOV. This means that the TVS can respond more quickly to transient voltage spikes and limit the voltage to a lower level. TVS are particularly effective at protecting against short-duration, high-frequency transients. It is also important to understand the difference in function between arrestor-rated and TVSS-rated SPD. Arrestor-rated SPD are primarily designed to protect against high-energy surges caused by external events such as lightning strikes or power grid disturbances. These surges can be characterized by high peak currents and long durations. Arrestor-rated SPD are typically installed at the service entrance of a building to protect the entire electrical system from these severe surges. In contrast, TVSS-rated SPD are primarily designed to protect against transient voltage spikes caused by internal events such as switching of electrical loads or operation of inductive equipment. These transients are typically characterized by lower peak currents and shorter durations than lightning surges. TVSS-rated SPD are often installed at branch circuits or individual equipment locations to protect sensitive electronic devices from these more common voltage spikes. Regarding the UL 1449 listing, UL 1449 is a safety standard for surge protective devices. It specifies the performance and safety requirements for a SPD intended for use in North America. UL 1449 includes various tests to evaluate the SPD ability to withstand surge currents, limit voltage, and maintain safety under fault conditions. The UL 1449 listing indicates that the SPD has been tested and certified by underwriters' laboratories, or all, to meet the requirements of the standard. As previously mentioned, Arrestor-rated SPD are typically UL 1449 listed for arrestor applications, while TVSS-rated SPD are typically UL 1449 Type 2 or Type 4 listed for TVSS applications. The different UL 1449 types indicate the SPD intended location and application. Type 1 SPD are intended for installation at the service entrance, while Type 2 SPD are intended for installation at branch circuits. Type 3 SPD are intended for installation at the point of utilization, and Type 4 SPD are component SPD. To understand the explosive requirement in NEC Section 280, the National Electrical Code, or NEC Section 280 addresses surge protection for electrical systems. It specifies the requirements for the installation and application of SPD in various types of occupancies. NEC Section 280 includes a specific requirement for SPD installed in locations where explosive atmospheres are present. In these locations, the NEC requires the use of arrestor-rated SPD. This requirement is intended to prevent the SPD from becoming a source of ignition in the presence of flammable gases or vapors. Arrestor-rated SPD are designed to safely handle high-energy surges without producing sparks or excessive heat that could ignite the surrounding atmosphere. Because of these risks, a parallel installation may be required. In some cases, it may be necessary to install an arrestor-rated SPD in parallel with a panel-installed SPD. This configuration can provide enhanced surge protection for the electrical system. The arrestor-rated SPD provides primary protection against high-energy surges, while the panel-installed SPD provides secondary protection against lower-energy transients. The parallel installation can also improve the overall reliability of the surge protection system. If one SPD fails, the other SPD can continue to provide protection. When installing SPD in parallel, it is important to ensure that the SPD are compatible with each other and that they are properly coordinated. The SPD should have similar voltage ratings and surge current capacities. The SPD should also be installed in accordance with the manufacturer's instructions and all applicable electrical codes. In summary, understanding the differences between arrestor-rated and TVSS-rated SPD is crucial for selecting the appropriate surge protection for a particular application. Arrestor-rated SPD are designed for high-energy surges, while TVSS-rated SPD are designed for transient voltage spikes. The UL 1449 listing provides assurance that the SPD has been tested and certified to meet safety and performance requirements. The NEC Section 280 includes specific requirements for SPD installed in locations where explosive atmospheres are present. Parallel installation of SPD can provide enhanced surge protection and improve the reliability of the electrical system. Let's delve a bit deeper into the technical specifications and considerations that differentiate arrestor-rated and TVSS-rated SPD. This will give you a more granular understanding of their applications and limitations. The key differences often lie in their surge handling capabilities, response times, and voltage clamping characteristics. When we talk about surge handling capabilities, we are referring to the amount of energy the SPD can absorb and dissipate without failing. A arrestor-rated SPD, designed for high-energy surges like those from lightning strikes, typically have significantly higher surge current ratings, often measured in kiloamps or kA. These ratings can range from tens of kA to hundreds of kA, depending on the application and the level of protection required. TVSS-rated SPDs, on the other hand, are designed for lower energy, shorter duration transients. Their surge current ratings are typically lower, often in the range of a few kA to tens of kA. This difference in surge handling capability reflects the different types of surges they are designed to protect against. A related parameter is the energy absorption capability, often expressed in joules. This indicates the total amount of energy the SPD can absorb over its lifespan. Again, arrestor-rated SPD typically have higher energy absorption capabilities compared to TVSS-rated SPD, consistent with their role in protecting against more severe surge events. Now, response time is another critical factor. This refers to the time it takes for the SPD to begin clamping the voltage once a surge is detected. Faster response times are generally better, as they allow the SPD to limit the voltage surge more quickly, protecting downstream equipment. TVSS-rated SPD often have faster response times than arrestor-rated SPD. This is because TVS, the primary surge-absorbing components in TVSS-rated SPD, are semiconductor devices that can switch very quickly. Arrestor-rated SPD, which may rely on spark-over gaps, can have slightly slower response times, although modern arrestor designs are constantly improving in this area. Voltage clamping characteristics are also important. The clamping voltage is the maximum voltage that the SPD will allow to pass through to the protected equipment during a surge event. Lower clamping voltages provide better protection, as they limit the voltage stress on downstream devices. TVSS-rated SPD often have lower clamping voltages than arrestor-rated SPD. This is because TVS are designed to clamp voltage more precisely and at lower levels. However, it's important to note that lower clamping voltages can also mean lower surge current handling capabilities. So there's often a trade-off between clamping voltage and surge current rating. Considering environmental factors is also important. The operating environment can also influence the choice between arrestor-rated and TVSS-rated SPD. For example, in harsh environments with high levels of humidity, dust, or vibration, arrestor-rated SPD may be more robust and reliable. This is because they are often designed with more rugged components and enclosures. In contrast, TVSS-rated SPD may be more sensitive to environmental factors and may require additional protection. Coordination with other protective devices is crucial too. SPD are often used in conjunction with other protective devices, such as circuit breakers and fuses. It's important to coordinate the SPD with these other devices to ensure that they work together effectively to protect the electrical system. For example, the SPD should be sized so that it can handle the surge current without causing the circuit breaker to trip unnecessarily. Similarly, the fuse should be sized to protect the SPD from overcurrent conditions. The location of installation is also important. The location where the SPD is installed can also affect its performance. SPD should be installed as close as possible to the equipment they are protecting. This minimizes the impedance of the wiring between the SPD and the equipment, which can reduce the effectiveness of the surge protection. In addition, SPD should be installed in locations where they are easily accessible for inspection and maintenance. Finally, let's talk about cost and lifecycle considerations. The cost of arrestor-rated and TVSS-rated SPD can vary significantly depending on their features and performance. Arrestor-rated SPD typically cost more than TVSS-rated SPD, reflecting their higher surge handling capabilities and more robust designs. However, it's important to consider the life cycle cost of the SPD, which includes not only the initial purchase price but also the cost of installation, maintenance, and replacement. SPD have a limited lifespan and will eventually need to be replaced. The lifespan of an SPD depends on the frequency and severity of surge events, as well as the quality of the SPD itself. It's important to monitor the SPD status and replace it when it reaches the end of its service life. This will ensure that the electrical system continues to be protected from surge damage. In conclusion, the choice between a Arrestor-rated and TVSS-rated SPD depends on a variety of factors, including the type of surges expected, the sensitivity of the protected equipment, the operating environment, and the overall surge protection strategy. By carefully considering these factors, you can select the appropriate SPD to protect your electrical system from surge damage. And remember to consult with a qualified electrical engineer or surge protection specialist to ensure that you are making the right choices for your specific application. Also, it's worth noting that some SPD are designed to provide both Arrestor-rated and TVSS-rated protection in a single device. These hybrid SPD combine the features of both types of SPD to provide comprehensive surge protection. They typically include both MOV and TVS, as well as other components such as filters and reactors. Hybrid SPD can be a good option for applications where both high energy surges and transient voltage spikes are a concern. The NEC is updated every 3 years, so it's essential to stay current with the latest requirements and recommendations for surge protection. The NEC provides detailed guidance on the selection, installation, and application of SPD in various types of occupancies. In addition to the NEC, there are other industry standards and guidelines that can be helpful in selecting and applying SPD. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. These standards provide detailed technical information on surge protection and can help you to make informed decisions about your surge protection strategy. Finally, it's important to remember that surge protection is an ongoing process. Surge protection devices should be inspected and tested regularly to ensure that they are functioning properly. The SPD status indicator should be checked periodically to see if it has experienced any surge events. If the SPD has reached the end of its service life, it should be replaced promptly. Surge protection should also be considered when making any changes to the electrical system. For example, when adding new equipment or modifying existing wiring, it's important to ensure that the surge protection is adequate for the new configuration. It is also important to ensure that the grounding system is properly installed and maintained. A good grounding system provides a low impedance path for surge currents to flow to ground, which can help to protect equipment from surge damage. The grounding system should be inspected regularly to ensure that it is in good condition. In addition to SPD, there are other surge protection techniques that can be used to protect equipment from surge damage. These include shielding, filtering, and isolation. Shielding involves enclosing sensitive equipment in a conductive enclosure to protect it from electromagnetic interference or EMI and surge currents. Filtering involves using filters to block unwanted frequencies and surge currents from entering the equipment. Isolation involves using transformers or other isolation devices to isolate the equipment from the electrical system. These techniques can be used in combination with SPD to provide comprehensive surge protection. Surge protection is an important aspect of electrical safety. By taking the necessary steps to protect your electrical system from surge damage, you can help to prevent equipment failures, fires, and other hazards. Remember to consult with a qualified electrical engineer or surge protection specialist to ensure that you are implementing the appropriate surge protection strategy for your specific needs. Also consider the specific voltage requirements of your equipment when selecting an SPD. SPD are available with different voltage ratings, and it's important to choose an SPD that is compatible with the voltage of the equipment you are protecting. Using an SPD with the wrong voltage rating can damage the SPD or the equipment it is protecting. Consider future expansion when selecting an SPD. If you anticipate adding more equipment to your electrical system in the future, it's important to select an SPD that can handle the additional load. Oversizing the SPD can provide additional protection and ensure that it will be able to meet your needs in the future. Also consider the reputation and experience of the SPD manufacturer. Choose an SPD from a reputable manufacturer with a proven track record of producing high-quality surge protection devices. Read reviews and compare products before making a purchase. Remember that surge protection is not a one-size-fits-all solution. The best surge protection strategy will depend on your specific needs and circumstances. Take the time to assess your risks and select the appropriate surge protection devices and techniques to protect your electrical system from surge damage.